Good day, everyone. Today, we will be discussing the hydrogen power plant, a modern concept in energy production that is gaining attention worldwide. A hydrogen power plant is a facility that generates electricity using hydrogen as its primary fuel. However, it is important to clarify that hydrogen is not a natural source of energy like coal or solar. Instead, it is an energy carrier. This means that energy must first be used to produce hydrogen, and only then it can be used to generate electricity. Hydrogen can be produced through different methods, such as steam methane reforming and electrolysis of water. Among these, electrolysis is considered cleaner when powered by a renewable energy sources like solar or wind. The reason hydrogen is being explored today is due to global concerns about climate change, pollution, and the depletion of fossil fuels. Traditional power plants release large amount of carbon dioxide, which contributes to a global warming. In contrast, hydrogen fuel system produce only water as a byproduct, making them environmentally friendly at to the point of use. Because of these advantages, hydrogen is seen as a potential solution for future energy systems, especially when combined with renewable energy. In this presentation, we will explore how hydrogen power plant works, their components, their advantages, and the challenges they face in becoming widely adopted.
So, to understand how hydrogen power plants works, let us look at overall system flow. So first, hydrogen is stored in large tank and supplied to fuel cells. Inside the fuel cells, hydrogen reacts with oxygen to generate electricity. This electricity is initially indirect current or DC form. The generated electricity is then stored in large battery system. These batteries act as energy stored to ensure stable and continuous power supply. Finally, the stored electricity is converted into alternating current or AC using inverters and delivered to power grid for distribution. It is important to note that this process involves multiple stages of energy conversion, which also means there are energy losses at each stages.
Next is hydrogen fuel cell operation. The core component of a hydrogen power plant is the hydrogen fuel cell. A fuel cell consists of three main parts: the anode, cathode, and electrolyte. Hydrogen gas enters the anode where it is split into protons and electrons. The electrons travel through an external circuit, creating an electric current. Meanwhile, the protons pass through the electrolyte to the cathode. At the cathode, oxygen combines with the protons and electrons to form water. The overall reaction produces electricity, water, and heat. Unlike combustion, this process is electrochemical, making it more efficient and environmental friendly. This is the main mechanism that allows hydrogen to be converted into usable electrical energy.
In addition to primary fuel cells, advanced battery energy storage systems play a crucial and complementary role within the architecture of modern hydrogen power plant. While fuel cells act as the main power generators by continuously converting hydrogen gas into electricity, they operate most efficiently and endure less wear when running at a steady, constant output. Batteries are integrated alongside them to create a highly responsive hybrid power setup, bridging the gap between steady chemical generation and dynamic real-world energy needs. The electricity generated by the fuel cells is not always used immediately by the grid, so the excess power is directed into high-capacity batteries for later use. Energy consumption fluctuates widely throughout the day, creating distinct peak and off-peak hours. Because it is inefficient to constantly throttle fuel cells up and down to chase these rapid load changes, the batteries absorbs the surplus energy during periods of low demand and instantly dispatch it during sudden spikes in power usage, helping to maintain a perfectly stable power supply. At a fundamental level, a battery works through reversible electrochemical reactions occurring between its two electrodes, the anode and the cathode, which are separated by an ion conducting electrolyte. During operation, an oxidation reaction at the anode releases electrons, which are forced to travel through an external circuit because the electrolyte blocks their direct internal path. This controlled flow of electrons is the electrical current we use. Meanwhile, positively charged ions move through the electrolyte to the cathode, where they recombine with the electrons to complete the cycle. Within the specific ecosystem of a hydrogen power plant, the battery bank acts as a critical electrical buffer and power conditioning system. It ensures that electricity can be delivered consistently, effectively smoothing out any operational transients. If there is a momentary drop in hydrogen supply pressure, a system startup delay, or an unexpected surge in grid demand, the batteries instantaneously inject power into the system. This rapid response time protects the delicate fuel cells from the stress of sudden load shifts and prevent voltage dips. Ultimately, integrating these storage devices makes the overall hydrogen power generation system significantly more reliable, flexible, and efficient. By allowing the batteries to handle the stressful fast charging electrical loads, the operational lifespan of the fuel cells is greatly extended, and overall maintenance costs are reduced. Together, they form a robust, zero-emission power plant capable of meeting the strict power quality and frequency regulation standards required by modern electrical grids.
I'm John Michael A. Rosario, and now let's talk about the advantages of hydrogen power plants. Hydrogen power plants offer several advantages compared to traditional energy systems. First, hydrogen has a high energy content per unit mass, making it a very efficient fuel. Second is that the only byproduct of hydrogen fuel cells is water, which means that there are no harmful emissions such as carbon dioxide. Additionally, fuel cells operate quietly and have a fewer moving parts, which reduces maintenance requirements. Hydrogen can also be produced from renewable energy sources, making it a very potential solution for sustainable energy in the future. These advantages make hydrogen a strong candidate for clean energy systems.
So hello everyone. Ngayon, pag-uusapan natin ang hydrogen power plants, isa sa mga pinaka-promising na clean energy technologies today. Habang patuloy na naghahanap ang mundo ng paraan para mabawasan ang carbon emissions, mas lalong nabibigyan ng pansin ang hydrogen bilang alternative fuel. Pero kahit maraming advantages, may mga challenges din ito. So sa video na ito, dalawang bagay ang tatalakayin natin. Una is yung real-world application ng hydrogen power plants at syempre sa pangalawa, ang mga challenges na humahadlang sa paggamit nito ng mas malawak. Simulan natin sa real-world applications. ang hydrogen power plants ay gumagawa ng kuryente gamit ang hydrogen gas, kadalasan through fuel cells or combustion systems. Ang pinakamalaking advantage nito ay kapag ginagamit ang hydrogen, tubig lang ang byproduct, kaya very clean at environment friendly. Una, ginagamit ito sa electricity generation. Sa ibang bansa, ginagamit ang hydrogen power plants para mag-supply ng kuryente, lalo na kapag mataas ang demand. Pwede rin itong magsilbing energy storage. Halimbawa, yung sobrang energy galing sa solar o wind, ginagamit para gumawa ng hydrogen. Tapos i-store at gagamitin ulit later para maging kuryente. Pangalawa, sa transportation. Ginagamit ang hydrogen fuel cells sa buses, trucks, trains, at kahit mga ships sa tubig. Advantage nito ay mas mabilis mag-refuel kumpara sa electric vehicles na kailangan pang i-charge ng matagal. Pangatlo, sa industrial use, yung mga heavy industries tulad ng steel at chemical production, nangangailangan ng sobrang init. Dito pumapasok ang hydrogen kasi kaya nitong mag-provide ng heat without producing carbon emissions. Pang-apat, ginagamit din ito sa mga remote or off-grid areas sa mga lugar na mahirap lagyan ng traditional power lines. Pwedeng gumamit ng hydrogen system para magkaroon ng stable na kuryente. At lastly, ginagamit din itong backup power. Halimbawa sa hospitals at data centers. Pwede itong maging alternative kapag nawalan ng kuryente. So ngayon naman, pag-uusapan natin ang challenges. Una, ang mataas na cost ng production. Ang paggawa ng hydrogen, lalo na yung tinatawag na green hydrogen, ay mahal. Yung process na electrolysis na naghihiwalay ng tubig into hydrogen at oxygen ay nangangailangan din ng malaking amount ng electricity. Pangalawa, efficiency issues. Kapag kinonvert mo ang electricity into hydrogen tapos ibabalik mo ulit sa electricity, may energy loss. Kaya minsan, mas efficient pa rin ang direct use ng renewable energy. Pangatlo, storage at transportation. Ang hydrogen ay sobrang gaan at madaling magliyab. Kailangan nito ng special tanks at mataas na pressure o sobrang lamig para ma-store ng maayos. Mahirap at mahal din itong i-transport. Pang-apat, kulang sa infrastructure. Wala pang sapat na pipelines, refueling stations, at facilities para sa hydrogen. Kailangan pa ng malaking investment para ma-develop ito. Pang-lima, safety concerns dahil flammable ang hydrogen. Kailangan ang maingat na handling kahit may safety measures na concern pa rin ito lalo na sa public perception. At syempre, ang panghuli ang source syempre ng hydrogen. Hindi lahat ng hydrogen ay clean. Marami pa rin ang galing sa fossil fuels na naglalabas pa rin ng carbon emissions. Kaya kailangan pa rin i-develop ang renewable methods para mas maging truly sustainable ito. So, in all lang naman, sa kabuuan, ang hydrogen power plants ay malaking potential sa future ng energy. Malinis ito, flexible at pwedeng gamitin sa iba't ibang sektor. Pero kailangan pa rin masolusyonan ang mga challenges tulad ng mataas na cost, efficiency issues, storage, at kakulangan sa infrastructure. Sa pag-unlad ng technology at mas maraming investment, possible na maging malaki bahagi ang hydrogen sa isang mas malinis at sustainable na mundo. Thank you.
Hydrogen power is considered one of the most promising clean energy solution today. However, despite its many advantages, it still faces several important challenges that must be addressed before it can be widely used on a global scale. First, let's talk about hydrogen production. Currently, most hydrogen is produced using natural gas through a process called steam methane reforming. While this method is efficient, it releases carbon dioxide into the atmosphere, which contributes to climate change. This somewhat defeats the purpose of hydrogen being a clean energy source. A cleaner alternative is electrolytes, where electricity is used to split water into hydrogen and oxygen. If the electricity used comes from renewable source like solar or wind, then the hydrogen produced is considered green hydrogen. However, the problem is that electrolysis is still very expensive and requires a large amount of energy. Because of this, it is not yet widely adopted for large-scale production. Another major challenge is store and transportation. Hydrogen has a very low energy density by volume, which means it takes up a lot of space compared to the other fuels. To store it efficiently, hydrogen must either be compressed at very high pressure or cooled to extreme low temperature to become liquid. Both methods requires advanced technology, increased cost, and add complexity to the system. Transporting hydrogen safely over long distance is also a challenge that engineers are still working to improve. Safety is also an important concern. Hydrogen is highly flammable and can leak easily because its molecules are very small. Even a tiny leak can pose a risk if not properly detected. Because of this, special materials, sensors, and safety systems are required when handling hydrogen in power plants and other applications. Despite these challenges, there are already real-world applications showing the potential of hydrogen power. For example, the Long Range Energy Project in the United States is one of the first power plant to use a mix of natural gas and hydrogen to generate electricity. This project demonstrates how hydrogen can gradually be integrated into existing energy system. Another example is the work being done by Siemens Energy, which is developing large-scale hydrogen technologies and combining them with renewable energy source. Their projects aims to produce green hydrogen and use it for power generation, industrial process, and even transportation. In addition to power plants, hydrogen is also being used in fuel cell for vehicle, backup power system, and industrial applications such as steel and chemical production. This real-world use shows that hydrogen is not just a concept, but a growing part of the modern energy landscape. In conclusion, hydrogen power has great potential to become a clean and sustainable energy solution for the future. However, challenges relate to production, storage cost, and safety still need to be addressed with continuous researching, innovation, and investment. Hydrogen could play a major role in reducing carbon emission and supporting the transition to renewable energy in the years to come.